All right, kiddos, back again with part 2. Now we're going to use the notes that we just wrote and the formulas, the fancy triangle, to help us practice a few of these, to help us solve a few of these practice problems, okay? So what I want you to do, make sure you're copying these notes, everything I'm doing. Make sure you copy in these problems, I meant to say, and as well as the answers, okay? So, number 1. It says a car drives 24 meters per second for 5 minutes, right? What distance does the car travel? So first things first, I noticed that we have 24 meters per second. Looking at our notes, I know that meters per second has to do with speed. 5 minutes, of course, that is time. They're asking for distance, right? So what we're going to do, use our handy dandy triangle. Since we're looking for distance, we're going to cover that up. That lets me know that we need to multiply speed multiplied by time, right? And do we have speed and time? 24 meters per second, 5 minutes. Yes, we do. So let's go ahead and multiply the two. 24, well, first of all, let's label it real quick. So we have speed and we have time, right? And we're looking for distance. So like I said, we're going to multiply the two. That's going to be 24 meters per second multiplied by 5 minutes. 24 multiplied by 5 is going to give us... All right, kiddos, back again with part 2. Now we're going to use the notes that we just wrote and the formulas, the fancy triangle, to help us practice a few of these, to help us solve a few of these practice problems, okay? So what I want you to do, make sure you're copying these notes, everything I'm doing. Make sure you copy in these problems, I meant to say, and as well as the answers, okay? So, number 1. It says a car drives 24 meters per second for 5 minutes, right? What distance does the car travel? So first things first, I noticed that we have 24 meters per second. Looking at our notes, I know that meters per second has to do with speed. 5 minutes, of course, that is time. They're asking for distance, right? So what we're going to do, use our handy dandy triangle. Since we're looking for distance, we're going to cover that up. That lets me know that we need to multiply speed multiplied by time, right? And do we have speed and time? 24 meters per second, 5 minutes. Yes, we do. So let's go ahead and multiply the two. 24, well, first of all, let's label it real quick. So we have speed and we have time, right? And we're looking for distance. So like I said, we're going to multiply the two. That's going to be 24 meters per second multiplied by 5 minutes. 24 multiplied by 5 is going to give us 120 meters, okay? Use your calculator, and we're looking for distance. How do we know that? We used our triangle method. So 120 meters, because that's what we're looking for. Distance is measured in meters. All right, copy this problem and write out the answer. Our second problem, it says an ant can travel approximately 30 meters per minute, right? 30 meters per minute. How many meters could an ant move in 45 minutes? So they gave us 45 minutes. Let's figure out, what do we have? 30 meters per minute. Do not know why I keep saying that. But 30 meters per minute, that is speed, right? That's how fast it's going per time. That's our speed. Of course, easy, it's 45 minutes, that's time. And again, any meters. So they're looking for distance again, right? So we're looking for distance. So distance is equal to, let's look at our triangle again. Cover it up. Speed multiplied by time. Do we have speed? Yes, 30 meters per minute. Do we have time? Yes, we do, 45 minutes. Let's multiply the two. 30 meters. I'm gonna put 30 m. Hopefully that's right. 30 meters per minute times 45 minutes. Or I can add in. There we go. That looks better. Equals. What's 30 times 45? Take out your calculator. Multiply. That's going to be 1,350 because we're talking about distance. Distance is a single unit, right? Distance is a single unit. We're looking at meters. That's our answer. 1,350 meters. Easy peasy. Number 2, an airplane flies 1,000 miles in 2 hours. What is the speed? This one let us know straight up what we're looking for. We're looking for speed, right? So I already know, cover up my triangle. I should be having distance divided by time. Let's see if we have distance. And let's see if we have time. An airplane flies 1,000 miles. Sounds like a distance to me. In 2 hours, sounds like time to me. What do we need to do with the two? According to our triangle, since we're looking for speed, notice how I'm covering it up. Distance divided by time. That's going to be 1,000 miles divided by 2 hours. 1,000 miles divided by 2 hours. Easy math. 1,000 divided by 2 is going to be 500. But 500 what? Since we're looking for speed, and you know speed is always distance over time, that's going to be 500 miles per hour. Put a box around there. Here's our answer. If Carolina throws a football 50 meters west, let's highlight that. 50 meters west in 2 seconds. What is the velocity? Oh my goodness, they're looking for velocity and we do not have that formula on our chart. Or do we? We actually do. So if you remember, speed and velocity are used as the same formula, right? Remember, speed and velocity both measure how fast an object goes. The only difference is velocity has a direction, right? But you use speed and velocity. The same formula you use for speed is going to be the exact same formula you use for velocity. So actually what I want you to do is add on the word velocity to your speed, okay? Because those two uses the same exact formula. And because they use the same exact formula, we have the formula for velocity. So, cover up velocity slash speed. We need to have distance divided by time. Let's see if we have distance. 50 meters west. Sounds like we got our distance to us. Do we have our time? 2 seconds. Looks like we got it to us. Velocity is equal to 50 meters west divided by 2 seconds. 50 divided by 2, so I have $50 and divided by 2 people. That's going to be 25. But what is our unit? Remember, you have to have distance and time with direction. So that's going to be 25 meters per second west. How do I know it's west? They gave it to us. Easy peasy, y'all. I promise it is. All right, number 5. A long problem, right? Looks tricky. It's not. So it says a motorcycle velocity at the top of the hill is 11.0 meters per second. 4 seconds later, so 4 seconds later, it reaches the bottom of the hill with a velocity of 20 meters per second. What is the acceleration? Do we have our acceleration formula? Yes, we do. What is the acceleration formula? What is the acceleration of the motorcycle? Now, according to our formula, we know in order to find acceleration, you have to subtract final velocity. Remember that lowercase f means your final velocity subtracted by your initial velocity. Initial is nothing but a fancy word for the beginning, right? So you subtract what you end with, subtract it from what you started with, divided by time. So we first have to figure out what are our velocities, what's our final velocity, and what's our beginning velocity. So let's reread the problem. A motorcycle velocity at the top of the hill is 11 meters, right? Per second. 4 seconds later, it reaches the bottom of the hill with a velocity of 20 meters per second. Sounds like this is going to be my final velocity, y'all. because that's what it ended with, and it started with 11. So what is the acceleration of the motorcycle? We have to have time. They gave us time right here. We have everything we need. Let's get to solving. So final velocity was 20. Subtracted from our beginning velocity, initial velocity, which is 11, divided by our time. Let's subtract. 20 minus 11 is going to be 9. 9 divided by 4, and then divided by 4. 9 divided by 4, take your calculator out again. Dun, dun, dun. 9 divided by 4 is 2.25, right? But of course, we can't leave it there. We have to put our unit of measurement. Since we're talking about acceleration, and if you remember from when we did force, mass, and acceleration is always measured in meters per second squared, right? That's our acceleration. And also, we have it in our notes. Acceleration, meters per second squared. All right, last practice problem. And then you're going to be doing some on your own. So make sure you're copying all of these down. So pause the video, copy the word problem, watch the video, add on the details and then answers. All right, last problem. A motorcycle traveling at 19 meters per second starts to slow down steadily, right? Meaning it's slowing down, you know, maybe it's at a stoplight. It's slowing down. You see it's turning yellow, then it turns red. Then it stops completely in 10 seconds. What is the motorcycle's acceleration? Again, we're looking for acceleration. That means, again, we're going to be using our final velocity minus initial velocity divided by time formula. So let's figure out our final velocity and our initial velocity. We see time is right here. That's easy. So let's see what we ended with and let's see what we started with. Let's reread the problem. A motorcycle traveling at 19 meters per second starts to slow down steadily. Then it stops completely. Now think about it. If I'm in a car, I'm going 19 meters per second, right? That's what I'm going. And then I stop and slow down completely. I come to a complete stop. What is my speed, you guys? What is my velocity? If I'm at a standstill, I'm not moving, I'm not going anywhere, I'm not going backwards. What is my speed? And if you guess 0, you're completely right. If I'm at a stoplight, if I'm not moving, I'm going 0 meters per second. I'm not moving, it's going 0. So that's our final velocity. Our initial velocity is 19 meters per second. Our final velocity, let's go ahead and start solving, is 0. Do not get scared because you see a 0, because remember, acceleration can be negative, right? So 0, which is our final velocity, minus what we started with is 19. Let me put the unit, because I want us to get the habit of writing our units every single time. Divided by our time, which is 10 seconds. Like I said, acceleration can be negative. Only thing that means is that it's slowing down, and in this case, our motorcycle did. 0 minus 19 is negative 19 divided by 10 seconds. Let's see. Divided by 10 seconds. You take your calculator out. Negative 19 divided by 10 is going to give us negative 1.9. Because we're talking about meters per second, acceleration, our unit is going to be meters per second squared. Like I said, acceleration, whenever you see a negative in front of it, it just means that it is slowing down, okay? And there we go. Copy these problems down, including the notes and the answers. Take a picture and submit for a grade. Talk to you later, kiddos. Bye.